Good morning or good afternoon to everyone in geometry today. So today we are going to take a look at conclusions beyond the basics. So for example, we're going to look at other reasons we could possibly use besides given information or the reflexive property that says, an angle is congruent to itself or a segment is congruent to itself, like a shared side or a shared angle. As well as vertical angles, where we would state vertical angles are congruent. So today I had you hopefully get 6 note cards. Doesn't matter what color. 1, 2, 3, 4, 5, and 6. And we are going to take a look at other possible reasons or statements we could make in a proof. So today we're going to focus on midpoint, segment bisector, angle bisector, isosceles triangle, right angles, and perpendicular segments. So that's why you have 6 note cards, 1 for each. So we're going to go ahead and get started. So you're going to take the first note card, I don't care what color it is, and you are going to fold it in half, hamburger style. So it looks like this. Okay, so you can fold all 6 of them while you're waiting, or you can just fold one at a time with me as we go along. So the first one, like I said, we're going to look at is midpoint. So on the front of the note card, we are going to write midpoint. And I'm just going to abbreviate M-I-D-P-T for midpoint. Now, when you think of, back to your definitions, when you have midpoint of a segment, what do you end up with? Hopefully you think about your definitions, you end up with congruent segments. So again, you should be filling out your note card with me as we go along here. So the front of it should say midpoint, and again, when you have a midpoint of a segment, you have congruent segments. So what we're going to do next is open up our note card. Okay, so on the top half and the inside, we're going to have a picture, and on the bottom half and the inside, we're going to have a little miniature proof. So in the top half, what I want you to do is draw me a triangle. So I drew a triangle, okay? You can label it whatever you like, but if you're going to be consistent with me, I'm going to label mine A, B, and C. Okay, so next, I'm going to draw in a segment from B, and I'm going to make it so that where it hits AC is the midpoint. I'm going to call this point D. Okay, so in this particular picture, we're going to do very short proofs today, just coming up with conclusions. So in this problem, we are given that D is the midpoint of segment AC. Okay, so again, at the bottom here, we're going to write a little miniature proof. So on the left side, we have our statements. On the right side, we have our reasons. Okay, so like we did before with our other proofs, we would start with our given. So our given statement is what we already have here, is that D is the midpoint of segment AC. And again, my reason is given. So to fill out the rest of it, we got to think about what should our conclusion be. Well, if you think back to your definition of a midpoint, if you have a midpoint of a segment, what happens? Well, the definition says it divides the segment into 2 congruent segments. So if segment AC is the segment, it's going to split this segment AC into 2 congruent segments. Those congruent segments would be segment AD and segment DC. So that's going to be my second step of my proof or my conclusion. So segment AD is going to be congruent to segment DC or CD. Remember, order of a segment doesn't matter. And my reason, based on a definition of a midpoint, now this is going to go back to conditional statements because we talked about them earlier last week. Okay, so what we're going to do is write the definition of a midpoint as a conditional statement. So it's going to go something like this. If a point is the midpoint of a segment, then it divides. Now I'm going to use like a little division symbol for divides. Then it divides the segment into two congruent segments. So again, as an if-then statement, a conditional statement, if a point is the midpoint of a segment, then it divides the segment into two congruent segments. Okay, don't make up your own version here. This is what I want you to write down. Okay, this is what I'm looking for. So if we need to pause the video, that's fine. But if a point is the midpoint of a segment, then it divides the segment into two congruent segments. So this is the reason we would use in a proof if we were told that we had a midpoint. When we have a midpoint, what's the conclusion we can reach? That we have two congruent segments. Okay, so we've got one down. So just put midpoint off to the side somewhere and we'll come back to it at the end. So grab your next note card, same way, fold it hamburger style, whatever color you want. So I'm going to do pink one next. On the front, this one is going to be about segment bisector. So on the front of the note card, write segment bisector. Now again, if you think back to your definitions, when you bisect a segment, so when you have a segment bisector, what do you end up with in the picture? You end up with congruent segments as well, just like midpoint. So I'm going to put a little box around this. So again, when I have a segment bisector in a picture, when we are told we have a segment bisector, we end up with congruent segments. So the front of the note card is hopefully something to look at and we can refer back to. So again, just a quick reference. If I have a segment bisector in the problem, what am I going to end up with somewhere in my proof? I'm going to know I have congruent segments. Remember, congruent segments are segments that have the same length. So what we're going to do next, open up the note card. So just like before, the top half we're going to put a picture, bottom half we're going to put a little mini proof. So I'm going to draw the same picture as I had in the last one. I'm trying to be consistent. Okay, so we have, again, triangle ABC, or however you want to label it. Okay, we're going to draw in that segment BD. So again, D is the middle of segment AC. So where in the last problem we looked at, it said D was the midpoint of segment AC. Since this problem is about a segment bisector, we're not going to say D is the midpoint. And this one, we are going to be given that segment BD bisects segment AC. So again, thinking about it, when you bisect a segment, you end up with congruent segments. So we're going to write our little miniature proof. So we've got, again, on the left side, we have our statements. And on the right side, we have our reasons. And a little side note, eventually this week, we'll get into more full proofs with this, proving triangles congruent by using some of these methods within it. Okay, we're just trying to look at other options. So my first statement, we're going to start with the given. So we're going to say segment BD bisects segment AC. My reason, it was given to us. It was part of the given information. Okay, so again, thinking back to the front, if we have a segment bisector, we have congruent segments. So in this picture, if segment BD bisects segment AC, the segments that we have are congruent are going to be segment AC, AD and DC. So that's my next step. So segment AD is congruent to segment DC. Now, since this problem is talking about a segment bisector, a segment bisecting a segment, our reason is not going to be about midpoint. It's going to be about a segment bisector. So if you need to, you look back at your vocabulary when you looked up your definitions last week, and you're going to write something very similar to this. Again, it's a conditional statement. So if a segment bisects a segment. Again, looking at your given, we have a segment bisecting a segment. So again, if a segment bisects a segment, then what did we say in the front of the note card? We had congruent segments. So we're going to say then it divides the segment into two congruent segments. So again, if a segment bisects a segment, then it divides the segment into two congruent segments. This is what you should have written down. If it's a little bit different, so be it, but don't make up your own. So again, if a segment bisects a segment, then it divides the segment into two congruent segments. So if you start off saying a segment was bisected, well, what's your conclusion? You're going to have congruent segments. Okay. We'll put that one off to the side with the other one. We got 4 to go. So pick a different card. Fold it again, hamburger style. Okay, so we just looked at segment bisector. This particular one is going to be angle bisector. So the difference between them, when I have a segment bisector, we're going to get congruent segments. Since we have an angle bisector,